Okay, continuing on with chapter 7, we're going to talk about similar triangles in section 7.4. And the learning outcome is the same as the last lesson, to demonstrate an understanding of similarity in polygons. We did similarity in polygons the last section, mostly quadrilaterals, and this one will do triangles. So very similar. Okay, so a triangle is a special polygon, obviously. And remember that when triangles are similar, we're going to have equal matching angles and we're going to have matching sides that are proportional. We talked about this in class quite a bit, actually, that the order in which similar triangles are named gives a lot of information, okay? So this particular example says that suppose triangle ABC is similar to triangle DEF. The way they're ordered lets us know which angles are equal. So A matches up with D, B matches up with E, and C matches up with F. Okay, that's not an accident that they're in that order, it's on purpose. And then remember too that we could say side AB matches up with DE. We could say side BC matches up with EF, and AC with DF. So the order is important. Okay, so let's use that knowledge to name the similar triangles. So I talked about in class that when they're sitting nice to each other all in the same orientation, it's really easy to see. This example isn't so easy to see because this one is pointing down and this one's pointing up. So the strategy that I use is I actually orient them so that they're exactly the same. So I'm going to leave this one as it is, and I'm going to turn this one. So I'm going to leave the first triangle as is, D, E, F. That's 4.8, that's 3.6, and that's 3. I am going to orient this one so it's the same. See how it's pointing up? I need it to point down. But look at how it needs to point down. What I want to do is I want to make sure that this side here is the longest length, so that's 3.2 over here. Okay, 4.8 is bigger than 3 and 3.6. So in this triangle, I want to make sure that the longest side goes on the top. And that's across from Y, so I'm going to make sure that Y is there. Now, this 3 here is the smallest, so I'm going to put the 2 there. Notice the 2 is side XY. I have a Y, so this is going to be side X. And the 2 was across from angle Z, this one's ZY, and ZY is 2.4. So if this triangle is similar to that one, remember the proportions will be the same. So I'm going to check these proportions here. I need to make sure that this divided by this is the same as this divided by that. And then I need to make sure that it's the same as this divided by that. Okay? So I'm going to take 4.8 and divide by 3.2, which gives me 1.5. Check the next one. 3.6 over 2.4. Again, 1.5. That's looking good. Last one, 3 over 2, we know is 1.5. Okay? So since these sides are in the correct proportion, I can now say that triangle DEF, in that order, is similar to triangle XZY. Okay? DEF, XZY. So drawing them next to each other in the same orientation can be very helpful in figuring out the similar triangle. So you're going to move on to the check. Try whatever strategy works for you and see if you can get this. So pause the recording, please. Give this a try and then come back and see if you did it right. Okay, so I'm going to go over this check. It says that 2 angles in each triangle are given. The measure of the third angle is 180 minus whatever's left over. Okay, remember all triangles add up to 180. So if we take 180, we subtract 68 and 36. We will get the leftover angle. So this one's easier than the example because we have the angle measures, and that helps much more than the side lengths, okay? So 76 is what's left, 36, 68, that has to be 76. So we can easily match up the angles, okay? So angle A is 76, which matches up with angle P. Angle B is 68, which matches up with Q. And let's see, 36, which matches up with R. Matching angles are equal, so the triangles are similar. Okay, so ABC, A matched with P, B matched with Q, and C matched with R. So ABC is similar to PQR. So nice and easy if we have the angle measures. Here we don't have the angle measures, we've got side lengths, okay? So again, my strategy, you don't have to follow it. If you can do this without doing it, don't bother. But my strategy is to turn one of the triangles so they have similar comparisons. So I'm going to turn the smaller one. I'm going to leave the first one just as is, and I'm going to make the second one look similar. And how it goes bigger, middle, small. So bigger would go here across from K. Bigger middle. Middle has to go here, so that's 1.6. Notice 1.6 is across from J, and then L is left, and across from L is 1.4. Okay, so that's the way that I can at least orient them so they look like each other. And that's kind of what they're going on in here. So it says in triangle DEF, order the sides from shortest to longest. Okay, so that's done. All right, find the scale factors of the matching sides. So my matching sides are this to this, this to that, and here to here. Okay, I'm going to get a little easy here. I'm not going to write all this stuff in. I'm just going to write in the numbers. 3.2 to 1.6 is a nice even 2. 5.4 to 2.7, 5.4 to 2.7, again another 2, and 2.8 to 1.4. There we go, another 2. All scale factors are equal, so the triangles are similar. Okay, so let's see. It says, I don't think you need to do that, but it says triangle DEF. So if we go DEF, we have to say LKJ. Okay. Example number 2, it says using similar triangles to determine a length. Okay, these two triangles are similar, find the length of TU. So again, they're not in the same orientation. I'm going to turn this one so that it looks exactly like this. Okay, look at how there's a dot there. I want a dot here. There's a curve, I want a curve. So let's look at it here. The curved one is R. The dot one's P. What's left over is Q. It says RP is 2, or you can even look at it like curved to dot. Curved to dot, RP is 2. And then QR, Q to R, or across from the dot is 3. And it wants us to find TU. So this is what we're finding, which matches with this. Okay, and look at how this one matches to that. So set up your ratio. I'm a fan of the ratios. Okay, SU over PR. SU over PR is the same as UT over RQ. Fill in your values. SU is 6. PR is 2. UT is my unknown. That's the one I'm solving for. RQ is 3. So I'm going to cross multiply, take the set I have, multiply, divide by the leftover. So I have 6 times 3, 18, divided by 2 is 9. So UT is 9. Okay, or you know what, even been easier, you could kind of just see, look at 6 or 2. Actually, let's go this way because 2. 2 divided, or 2 times 3 is 6. So 3 times 3 is 9. You might have caught that one a little faster. Either way, it's fine. All right, so let's try this check. Pause here, give it a try. Practice rewriting those triangles, and then come back and see if you got it right. I'm most likely going to ignore all this stuff, though. Okay, so I'm going to go over this example number 1. Okay. So these two triangles are similar. Find the length of XV. So we, I could highlight it, but look at how small it is. That's not that helpful. I'm going to redraw it though. So I want to redraw this triangle with this orientation. So I'm going to draw it a little bigger just so I can use it. Okay, there's my 90 degree. This is my dot. Okay. So have a look at the picture that I just kind of wrecked here, and let's put the information that we know. Okay, the 90 degree is X. The dot is W. And if XW is 2, what's left over is V. Okay, so let's match up our sides. This is the same as that. This is the same as that. So my ratio would look like FH to XW, same as FG to XV. Plug in your numbers. 10 to 2 is the same as 20 to XV. Cross multiply. 2 times 20 is 40. Divided by the leftover is 4, which makes sense. 10 got doubled, so 2 has to get doubled. So this length is 4. That's it. Good luck on your homework and your quiz.